considering only the values of theta for which it's defined, there's some values for some trig functions where it's undefined. Secant squared theta cosine 2 theta equals something. We're just supposed to simplify this expression. So secant squared theta, secant squared theta, and I'm going to rewrite cosine 2 theta with something that I think is going to make stuff cancel out. And I'm keeping in mind secant squared is 1 over cosine squared. Right? So, cosine has 3 different options if you pull up this formula on the web. Which one is best? Let's try this one first, and if we don't simplify to something nice and clean, we'll do the other ones because they're all equivalent to each other. It'll all get us to the right place. So cosine squared theta minus sine squared theta. And look, secant we said is 1 over cosine squared theta. So you're multiplying that to everything inside the parentheses. And so when you distribute, you get 1 minus, this is going to be 1 times sine squared is sine squared theta, and cosine squared theta on the denominator. So that's tangent. That's almost an identity that we want, but I don't think it's going to work. Because we have this Pythagorean identity that tangent squared theta plus 1 equals secant squared theta. Right, so maybe could we rearrange this? I don't think we can. They have to be the same sign in order to make this work. So that's not going to simplify like we want. And it's none of the options up here. So let's see what else we can do. Instead of using cosine squared, sine squared, let's retry. Instead of cosine 2 theta, we'll use this one, okay? Secant squared theta times, I just had an idea of how we could have simplified that other one, but let's go with, let's do attempt number 2 to see if it simplifies nice and clean. Cosine squared theta minus 1. And we know secant and cosine are reciprocals, so when you distribute, that's just going to make 2 times 1. And we still have secant squared theta over here. That's an option, so that's the one we want to fill in. Okay. If this is multiple select, we'd have to keep going, try out all the options and see if we can simplify. But we found it. When we use the second version of the cosine double angle identity, we got this one here. Double angle identities again. This one's actually kind of similar to the one we just saw. Why won't that stay up? Come on. There we go. Okay. Cosecant squared beta. I'm going to use x. I don't like writing beta. So we got cosecant squared x times cosine of 2x. So using the formulas over here, we got to match it with something over on the left side. So it could be any one of these 3. Let's just try this one because it involves just sine. And I'm thinking that might make things easier. Because I know sine and cosecant are reciprocals. So I'm thinking that'll simplify nicely. So I'm rewriting cosine of 2x as 1 minus 2 sine squared x. And so if you distribute the cosecant, cosecant times sine, that makes 1. And that's not one of our options. What can we do? Let's go back to the drawing board. Let's try it again with cosecant squared x. We'll use the top one for cosine. And so if you distribute, this is 1 over sine squared x, right? So if you distribute that, you're going to get cosine squared x over sine squared x. And now when you distribute and multiply over here, those are going to cancel out, makes 1. And this is cotangent, right? Cosine over sine is cotangent. So cosine squared over sine squared is cotangent squared. Is that an option? Yeah, that's our one right there. So with cosine, unfortunately, just got to play around a little bit. Try a couple of different formulas until it matches up with one of your multiple choice options.